everybody. Today we have another video for number theory. Okay, here we go. And then we're going to talk about the greatest common divisor, popularly known or commonly known as the GCD. Okay, so there is a positive integer. There exists some positive integer, okay, which can be a factor of two positive integers a and b. So let's say we say let a, b, and c be integers. Okay, and there will be some c, say c is a factor of a and c is also a factor of b. Then we call this we call c as a common factor or common divisor of a and b. Okay, so it's gonna be a common factor or common divisor if this certain c divides both a and b. Okay, so to cite some examples, so for example, let's take a look at 12 and 18. Now, actually, 12 and 18, um, they have four common factors. Or let's use the word divisor, common divisors. That is 1, 2, 3, and 6. Notice all these numbers can divide both of them, and it is common to both of them. Of course, 1 is a trivial common factor. It is a common factor for all other numbers. Okay, so whereas, as another example, um, say we have 12 and 25. For 12 and 25, they have exactly one common divisor. One common divisor, and that is the one I said, the trivial one. Okay, so in both of these examples, for the pair of numbers 12 and 18, they have four common factors. Okay, so they have four common factors, four. But in the next example, 12 and 25, they have exactly one common factor, which is one. And there will be a special case for this second example. Actually, we will talk about that later. Okay, so those are what we call common factors. All right, so often we are not interested in all common factors of arbitrary integers a and b. So we are not really interested in all of the factors of a and b, but we are um, very interested in the largest common factor or the largest common divisor. Okay, that is what we call the greatest common divisor, and then we will define that in this definition now. Okay, so definition. So this definition is the definition of the greatest common divisor. Okay, so how do we define this? So we will let a and b be given integers with at least this is at least one of them different from zero. Okay, with at least one of them different from zero. Okay, so the greatest common factor, the greatest common, say divisor, sorry, I always use the word factor. The greatest common divisor, okay, of A and B, of A and B, we denote that by denoted by GCD of A and B. So we read this as the greatest common factor, or the GCD for short, or greatest common divisor. GCD of A and B is something, especially if it has an equal sign, is, for example, 3. So the GCD of A and B is equal to 3. So we denote that as this. Okay, so therefore the greatest common divisor of A and B, okay, is the positive integer B, D rather, is D, which is in the positive integers. Oops, sorry. D, which is in the positive integers. Okay, satisfying the following conditions. Satisfying the following. So first condition, number 1, this D, okay, the GCD of A and B must be a factor of A, and it should also be a factor of B rather. So this is our um, first first condition. So D should divide A, and at the same time it should divide B. Second condition, if there's a certain C that divides A, and also a certain C, the same C, that divides B, then this C is less than or equal to D, where C is also a positive integer. Okay, so that's it. So the D, the greatest common divisor, divides A, and also it divides B. And then if there is a certain C that divides A and divides B, it should be less than or equal to D, not greater than D, because we say that D is the greatest common divisor. So it's the greatest, the largest, the highest, where C is also the positive integer. So meaning C is not the greatest. It is a common divisor, but it's not the greatest common divisor. Okay, so we then say that thus D, to complete the equation, D is what we call the greatest common divisor of A and B. Okay, if two conditions are satisfied. If you want this statement in words, so let's have it. So in words, we say, just to clarify the statements above, D must be a common factor. Factor of A and B. And number 2, D must be the largest common factor. D must be the largest common factor. Okay, of A and B. So in other words, any other common factor C, any other common factor C must be less than, okay, must be less than or equal to D. Okay, so that is what the definition is actually telling us. Okay, so in worded format. Okay, so again, let us see the definition of a greatest common divisor. So a greatest common divisor is, sorry. So a greatest common divisor, yeah, something like that. Okay, so the greatest common divisor is we will first let a and b to be integers with at least or greater than or equal to one of them different from 0. So the greatest common divisor of a and b denoted by GCD of a and b is equal to d. Okay, this d satisfies the following condition. D must be a common factor or a common divisor of both a and b. So which means d divides a and also d divides b. Number two, if there's a certain c that is also a common factor, which is c divides a and c divides b, then this c must be less than or equal to d, not greater than, because d is the greatest. So it can always only be less than or equal to d. Okay, so where c is a positive integer. So in words, d is equal to GCD of a and b if two conditions are satisfied. D must be a common factor of ab. That's the first one. Secondly, d must be the largest common factor. If there is any other common factor c, so therefore this certain c must be less than or equal to d. Okay, so that is quite a mouthful. Let's have some examples, shall we? So as an example, the positive divisors of minus 12 is, okay, the positive divisors of minus 12, okay, are, we have 1, 2, 3, 4, 6, and 12. Okay, whereas 30, okay, 30 has 1, 2, 3, 5, 6, 10, 15, and 30 itself. Okay, that's quite a lot. Hence, from this, hence, hence, since we have minus 12 and positive 30, hence, the positive common divisors, okay, the positive common divisors of minus 12 and 30 are, so what are those which are positive to both negative 12 and 30? Only for the positive divisors. So we have 1, that's trivial. We have 2, let's also have it because they're both even. We have 3, meaning they're all multiples of 3. And we have also, there's no 4 here, there's no 5 here. 6, yeah, 6. 6 is common to both of them. 10, 10 is not. 15 is not. 30 is not, of course. 15 and 30 are more than 12, so it cannot be. So as you can see, these are the common factors of 12 and 30. So we have 1, 2, 3, and 6. Okay, and 6. So since we can see here that 6, okay, since 6 is the largest of all the common divisors in this pair, negative 12 and 30. So therefore, we say that so GCD of minus 12 and 30 is equal to 6. Okay, for the positive divisors of minus 12. So in the same way, we can also show that the greatest common divisor, the GCD of minus 5 and 5, is equal to positive 5. Okay, so since negative 5 can be shown as 5 times negative 1, so 5 is still a common divisor. We can also say that the GCD of 8 and 17 is equal to 1, and also similarly, we can also say the GCD of minus 8 and minus 36 is equal to 4. Why is it 4? 8 or negative 8 can be written as minus 2 times 4. 36 can also be written, 4 times negative 9. So that's the common factor for both the numbers negative 8 and negative 36. Now, I want you to focus your attention on the second, on the middle example, specifically here. So the GCD of 8 and 17 is 1. So this is one of those e- examples or numbers, a pair of numbers that only has a trivial factor of 1. Okay, only 1. So meaning if that happens, we can say that these numbers 8 and 17 are said to be relatively prime. Again, so 8 and 17 are said to be relatively prime. So let's put that here. So let's have another definition. I hope it fits. So we call this definition relatively prime, or maybe let's transfer it here. We have no more space down below. Oops. Yeah, over here. Okay. So we're running out of space. Yeah, very normal in a pure maths class. Okay, if this is a real blackboard, whiteboard, it will always be erased, actually. So yeah, let's do it here. Definition. Definition of relatively prime. So two positive integers, a and b. So a and b, which are positive integers, okay, are said to be relatively prime. They are said to be relatively prime if the GCD of a and b is equal to 1. Okay, again, just like in our example in here, so 8 and 17, 8 and 17, they have a common factor of 1, so therefore 8 and 17 are said to be relatively prime. Okay, what are the other examples of integers which are relatively prime? So therefore, we can also say, for example, that the GCD of 6 and 35 is 1. Okay, the factors of 6 is easy to determine. We have 1, 2, 3, and 6. And 1, 2, 3, and 6 are not all factors of 35 because the factors of 35 is 7 and 5, both prime. So again, to show you, so 6 can be 1, let's make it a single line. 6 can be 1, it has common divisors or divisors as 1, 2, 3, and 6, while 35 has common divisors of 7 and 5. So as you can see, there's no common, and of course 1, I forgot. Okay, so 1 is the only common divisor for both of them. So therefore, we can say that 6 and 35 are relatively prime. One more example, shall we? Last example is the GCD of 11 and 24. Automatically, since 11 is a prime number, it is relatively prime. Okay, this pair is relatively prime. So 11, 24 are relatively primes. Okay, so I think that's enough for this video right now. We have talked about quite a lot. Let's have a zoom out of how much have we talked already. Yeah. Okay, here we go. We started off with okay, we started off okay with this title, so the greatest common divisor. So we have three integers, preferably positive. If c divides a and c divides b, so we call c as a common factor or a common divisor of a and b. So we have given examples here of common divisors. We have defined formally what it means when you say that a number is a common is the greatest common divisor. Let me click on zoom in. Okay, we have defined that, and it has two conditions. Okay, the GCD is equal to this certain D, this certain value D here, if two conditions are met, if D is a common factor of both A and B, and that if there exists any factor C, so this C must be less than or equal to D, meaning D is the greatest common divisor. So we have stated some examples, and we have wondered about this example here in the green box, wherein the GCD is 1. So we say and define that if ever this happens, we will call this pair of numbers as relatively prime. So if we have A and B to be positive integers, they are said to be relatively prime if their GCD is equal to 1. And we have cited examples also. Okay, so I think that's it for this video. Thank you very much for watching. I hope you stood still okay during the whole time of discussion. And yeah, thank you very much, and I'll see you soon. Bye.